India's Chandrayaan-3 mission has uncovered evidence suggesting lunar water may be more accessible than scientists previously believed.
Not long ago, we shared the exciting news about India's incredible achievement with its Chandrayaan-3 lunar mission, a true milestone in space history. Chandrayaan-3 didn't just land on the moon, it made history by becoming the first mission ever to successfully land in the moon's mysterious South Pole region. That accomplishment instantly placed India in an elite group, making it only the fourth country after the United States, the former Soviet Union, and China to achieve a successful soft landing on the lunar surface. In our previous coverage, we took a deep dive into what the Chandrayaan-3 mission is all about, how it was engineered, the complex landing sequence, and the very real challenges the team had to overcome to reach one of the most rugged, shadow-filled, and unexplored regions of the moon. We also talked about why this specific area, the lunar South Pole, has become such a hot topic in space science, and why its unique environment might hold clues to the moon's origin and even the future of human space travel. But here's the thing, the landing was only the opening chapter. Since its arrival, Chandrayaan-3 has quietly kicked into exploration mode, and it's already started uncovering some fascinating insights. The spacecraft isn't just sitting there, it's actively studying its surroundings, gathering scientific data, and sending back stunning visuals from a part of the moon we've never seen up close. And now, we've got some brand new images and updates to share that are truly next level. In this segment, we're going to walk you through exactly what Chandrayaan-3 has accomplished since the landing, what kind of data it has gathered, and, more importantly, what these early findings could mean for our understanding of the moon's history and its potential to support future missions. But before we get into the science, let's take a moment to appreciate one of the most breathtaking pieces of footage we've received so far, a video showing the Pragyan rover making its descent onto the moon's surface, captured by none other than the Vikram lander itself. This isn't just a cool video clip, it's a front row seat to a delicate and high-stakes maneuver that had to go absolutely perfectly. The footage was captured by Vikram's top-mounted imager camera, which plays a crucial role in observing the surroundings and maintaining visual contact with the Pragyan rover. It's essentially Vikram's eyes on the surface, monitoring, guiding, and ensuring everything goes smoothly. In the video, we see the Pragyan rover slowly rolling down a specially designed ramp that unfolds from the underside of the Vikram lander. The movement is incredibly precise and almost suspenseful, like watching a tightrope walker take their first step. Every inch the rover moves is calculated and cautious because the terrain beneath is full of unexpected dips, rocks, and slopes. This isn't a flat parking lot. It's the rugged, uncharted frontier of the moon's South Pole. And yet, as the rover touches down, it does so gracefully, with the Vikram lander positioned just above like a watchful guardian. This wasn't just a technical success, it was a visual and emotional one. Seeing one robotic explorer release another onto the surface of a distant world is the kind of moment that makes space exploration feel real, tangible, even poetic. But beyond the drama of the descent lies the real mission, exploration. With Pragyan now fully mobile, it started scanning the moon's surface, analyzing soil composition, searching for key elements, and mapping the area inch by inch. Meanwhile, Vikram continues to serve as the command post, relaying information and supporting Pragyan's movements as it ventures farther out. And the best part, this is just the beginning. The data these two machines collect, temperature readings, surface composition, mineral detection, could offer valuable insights into how the moon formed, what resources are buried beneath the surface, and whether this region could one day support human life or long-term lunar bases. It's an unfolding story of exploration, teamwork, and technological brilliance, and we can't wait to show you what comes next.
As you watch the footage, listen closely. You'll hear a series of beeps and distant voices in the background. Those aren't just background noise. That's mission control in action, tracking every critical second of the descent. Each beep and call-out is a sign of how things are progressing. But here's something important to understand. Even though Earth-based engineers were monitoring everything, they weren't in real-time control of the landing. Why? Because of the time delay. It takes about 1.3 seconds for a command to travel from Earth to the moon and another 1.3 seconds to get a response back. That small delay may not sound like much, but in space exploration, that's an eternity when milliseconds count. That's why the Chandrayaan-3 mission was designed to be autonomous. The Vikram lander and Pragyan rover had to think for themselves. Thanks to their advanced onboard computers, sensors, and pre-programmed instructions, both machines worked in sync, relying on on their own logic, decision-making systems, and internal navigation to carry out one of the most delicate operations in space exploration, a soft landing on an unfamiliar, unforgiving surface. This video is more than just a fascinating piece of footage. It's proof of how brilliantly Vikram and Pragyan performed together. Like seasoned astronauts, they executed their roles flawlessly without any hand-holding from Earth.
Once Pragyan made it safely onto the surface, it wasted no time getting to work. One of the first things it did was capture a jaw-dropping image of the Vikram lander standing tall and proud on the moon. This wasn't just a quick snapshot. This image came from Pragyan's front-mounted navigation camera, designed to help it move, avoid hazards, and document its surroundings. The photo it captured is both technically remarkable and emotionally powerful. The Vikram lander, upright on its 4 sturdy legs, perched on a flat patch of lunar soil near a small crater. It looks like something out of a science fiction movie, but it's very real. In the image, you can clearly see the base of the lander, including its main engine, the one that slowed its descent and helped it achieve a precise, soft landing. That engine had to fire just right, at just the right time, in order to counter the gravity of the moon and guide the lander gently to the surface. The fact that it's standing there, completely stable, is a testament to the precision of India's engineers and the strength of their design. This photo isn't just a keepsake, it's solid, visual proof of India's success on the moon. Landing safely in the moon's south polar region isn't just hard, it's one of the most technically demanding things a space agency can attempt, and India pulled it off. In the next section, we'll dive into another incredible video showing how the Pragyan rover navigates across this challenging terrain, identifying and avoiding hazards in real time. But for now, let's take a moment to appreciate this powerful moment, a robotic partnership 238,000 miles from Earth, silently celebrating a historic achievement. To fully appreciate the magnitude of India's Chandrayaan-3 achievement, let's take a step back. Only 3 other nations in history, the United States, Russia, formerly the Soviet Union, and China, have ever managed to successfully land a spacecraft on the moon. That's it, just 3. Why so few? Because landing on the moon isn't just difficult. It's a high-stakes balancing act that leaves 0 room for error. Every second of descent requires flawless timing, precise navigation, and the careful control of both speed and altitude. One wrong move, a faulty sensor, a miscalculated thruster burn, a software glitch, and your spacecraft could go from hero to crater in seconds. That's why in the world of space exploration, the landing is often called the most difficult and dangerous part of any lunar mission. And yet, here we are, watching a machine from Earth sit firmly on the rugged surface of the moon's south pole, sending back images that make it all feel so real. One of those images in particular stands out, not just because it confirms a flawless landing, but because of what it represents. It's more than a photo of a machine on the moon. It's a tribute to a dreamer, to a visionary whose ideas helped turn science fiction into India's space reality. That dreamer was Dr. Vikram Sarabhai, the man often hailed as the father of India's space program. Back in 1969, when the idea of space exploration in India was still considered a fantasy, Sarabhai dared to believe that a developing country like India could not only participate in space exploration, but lead it. He founded ISRO, India's space agency, and laid the foundation for missions like Chandrayaan-3 to even be possible. His influence extended far beyond rockets and satellites. He was also a trailblazer in nuclear physics, meteorology, education, and even social and industrial development. Every bolt and wire in Chandrayaan-3 carries the spirit of his vision. Naming the lander Vikram is not just a nod, it's a legacy being fulfilled, and that legacy continues in motion. Literally, in the next breathtaking segment of this story, we witness another video, this time from the Pragyan rover itself. Using its front-facing navigation camera, Pragyan records its slow, deliberate movement across the moon's surface. Watching it roll forward is like seeing a child take its first steps on a new planet. Its 6 wheels, each carefully engineered for this harsh terrain, dig into the moon's soil and propel the rover forward, powered entirely by the sun's energy. It's a surreal dance between machine and moon. This humble-looking vehicle, about the size of a small suitcase, is actually the heart of the Chandrayaan-3 mission. It's not just rolling around for fun. Pragyan was built to explore the moon's south pole, an area shrouded in mystery and brimming with scientific potential. Its job? to perform experiments, gather data, analyze surface composition, and push the boundaries of what we know about Earth's celestial neighbor. The rover can travel as far as 500 meters, about a third of a mile, from the Vikram lander, like a child staying close to its parent but still exploring independently. Communication is key, and Pragyan uses radio signals to stay in constant contact with Vikram, which in turn relays the data back to Earth. But don't be fooled. Driving on the moon isn't like cruising through your neighborhood. Every inch of progress is a battle. Pragyan has to navigate a minefield of obstacles: sharp slopes, jagged rocks, low gravity, and swirling clouds of moon dust that could interfere with its instruments. The surface is uneven, and the temperatures swing between extremes: blistering heat during the day and freezing cold at night. And let's not forget, the moon has no atmosphere, which means there's no cushion, no protection, and no second chances. Yet despite all of this, Pragyan keeps moving. Its wheels grip, its sensors scan, its brain crafted by Indian scientists keeps it steady and focused. Every turn of those wheels, every centimeter forward, is a small miracle in a mission full of big ones.
Now let's take a closer look at how the Pragyan rover handles the harsh and unpredictable environment of the moon. This isn't just a casual stroll on alien soil, it's a highly calculated survival mission, full of physical challenges that would push even the toughest machines to their limits. Let's start with gravity, or the lack of it. The moon's gravity is just about 1/6 of what we feel here on Earth. That means the Pragyan rover, which might be heavy down here, weighs far less up there. Sounds cool, right? But there's a catch. That lower gravity also means less grip on the ground, making it much easier for the rover to slip, bounce, or even tip over if it's not careful. Imagine trying to walk on ice while carrying a tray of delicate instruments. That's what it's like for Pragyan. So how does it manage? Engineers thought ahead. The rover is equipped with a smart suspension system that allows it to flex, tilt, and adjust to the unpredictable contours of the moon's surface. This system helps it maintain balance even on jagged rocks or shifting slopes. And to reduce the risk of sliding or losing control, its speed is capped at a super slow 1 centimeter per second. That's right, just 0.6 meters per minute. It may not be fast, but it's focused, steady, and safe. Now let's talk about the terrain, because the moon is anything but smooth. Pragyan is navigating across an environment full of craters, ridges, boulders, and valleys, all without the help of roads or any kind of markings. It's literally blazing its own trail across a gray alien wilderness. One wrong move could send it rolling into a crater or stuck behind a rock it can't climb. To tackle this, the rover relies on a cutting-edge navigation system packed with high-res cameras, sensors, and onboard algorithms. Think of it like a lunar GPS crossed with a self-driving car brain. It scans the ground ahead, processes the shape and elevation of nearby features, and calculates the safest and most efficient route forward. And it's not just reacting, it's predicting and planning, avoiding hazards before they become problems. If it detects something dangerous, like a sharp incline or a boulder the size of a small house, it automatically reroutes itself. But there's another sneaky enemy on the moon: dust, and not the kind you wipe off your bookshelf. Lunar dust is fine, clingy, and abrasive, like microscopic glass shards that stick to everything. It's so persistent, it can coat solar panels, jam moving parts, and blur camera lenses. In short, it's a serious threat to any robotic explorer's health. Knowing this, the scientists behind Chandrayaan-3 gave Pragyan a dust defense toolkit. This includes miniature brushes, air blowers, and even internal heaters that can clean off sensitive equipment and keep critical parts functioning. This self-cleaning system helps maintain power, protect vision systems, and ensure that the rover doesn't slowly choke on the very surface it's trying to explore. So, while it may look like a quiet little machine silently gliding across the moon's surface, every inch of progress is a battle against nature, waged with cutting-edge technology and brilliant engineering. And Pragyan, it's holding its own like a true space explorer.
Now, let's take a closer look at how the Pragyan rover handles the harsh and unpredictable environment of the moon. This isn't just a casual stroll on alien soil. It's a highly calculated survival mission, full of physical challenges that would push even the toughest machines to their limits. Let's start with gravity, or the lack of it. The moon's gravity is just about 1/6 of what we feel here on Earth. That means the Pragyan rover, which might be heavy down here, weighs far less up there. Sounds cool, right?
But there's a catch. That lower gravity also means less grip on the ground, making it much easier for the rover to slip, bounce, or even tip over if it's not careful. Imagine trying to walk on ice while carrying a tray of delicate instruments. That's what it's like for Pragyan. So how does it manage? Engineers thought ahead. The rover is equipped with a smart suspension system that allows it to flex, tilt, and adjust to the unpredictable contours of the moon's surface. This system helps it maintain balance, even on jagged rocks or shifting slopes. And to reduce the risk of sliding or losing control, its speed is capped at a super slow 1 centimeter per second. That's right, just 0.6 meters per minute. It may not be fast, but it's focused, steady, and safe. Now, let's talk about the terrain. Because the moon is anything but smooth. Pragyan is navigating across an environment full of craters, ridges, boulders, and valleys, all without the help of roads or any kind of markings. It's literally blazing its own trail across a great alien wilderness. One wrong move could send it rolling into a crater or stuck behind a rock it can't climb. To tackle this, the rover relies on a cutting-edge navigation system packed with high-res cameras, sensors, and onboard algorithms. Think of it like a lunar GPS crossed with a self-driving car brain. It scans the ground ahead, processes the shape and elevation of nearby features, and calculates the safest and most efficient route forward. And it's not just reacting, it's predicting and planning, avoiding hazards before they become problems. If it detects something dangerous, like a sharp incline or a boulder the size of a small house, it automatically reroutes itself. But there's another sneaky enemy on the moon: dust. And not the kind you wipe off your bookshelf. Lunar dust is fine, clingy, and abrasive, like microscopic glass shards that stick to everything. It's so persistent it can coat solar panels, jam moving parts, and blur camera lenses. In short, it's a serious threat to any robotic explorer's health. So, knowing this, the scientists behind Chandrayaan-3 gave Pragyan a dust defense toolkit. This includes miniature brushes, air blowers, and even internal heaters that can clean off sensitive equipment and keep critical parts functioning. This self-cleaning system helps maintain power, protect vision systems, and ensure that the rover doesn't slowly choke on the very surface it's trying to explore. So while it may look like a quiet little machine silently gliding across the moon's surface, every inch of progress is a battle against nature, waged with cutting-edge technology and brilliant engineering. And Pragyan, it's holding its own like a true space explorer.
Here's something that really shows how tough and smart the Pragyan rover is. One of the biggest challenges it faces on the moon is dealing with extreme temperature swings. We're talking about nighttime lows of minus 156 degrees Celsius, that's minus 249 degrees Fahrenheit, and daytime highs that shoot up to plus 121 degrees, about 250 degrees Fahrenheit. These wild shifts happen depending on whether an area is bathed in sunlight or plunged into shadow, and they can put serious stress on the rover's instruments and systems. To survive in these brutal conditions, Pragyan is equipped with a highly engineered thermal control system. It uses a combination of insulation, built-in heaters, and radiators to regulate its internal temperature and keep all of its components operating safely even when the lunar surface is freezing or scorching hot. So while the moon's environment is incredibly hostile, Pragyan's built to handle it. This isn't just a machine, it's a resilient, adaptable explorer designed to thrive in one of the harshest places imaginable. But it's not just tough, it's curious too. Pragyan was designed to seek out new data and help us learn more about the moon, especially in unexplored regions. One key tool helping it do that is the LIBS instrument, short for laser-induced breakdown spectroscopy. This cutting-edge tech allows the rover to analyze the chemical makeup of lunar soil samples. How does it work? Simple in concept, high-tech in execution. The instrument fires powerful laser pulses at a soil sample. That energy creates an incredibly hot, focused plasma right on the surface. As that plasma cools, it emits light, and here's where it gets cool. Each element gives off a specific light signature, like a chemical fingerprint. LIBS captures that light and breaks it down into its wavelengths to figure out exactly what elements are present. The result? A bar graph showing the percentages of different elements found in the sample. Valuable clues that help scientists piece together the moon's history, structure, and potential resources. Pragyan may be small, but it's doing big science. It's not just surviving on the moon, it's helping us understand it. One of the most important goals of this mission is to study the composition of lunar soil in the moon's South Pole region, an area that's very different from the more familiar equatorial zones we've explored in the past. Why does this matter? because the makeup of the soil can reveal huge clues about how the moon formed, how it's changed over billions of years, and what kind of geological activity it's experienced. And here's where things got really interesting. The analysis revealed something totally unexpected: high levels of sulfur in the soil. That's a big deal. Sulfur isn't just a random trace element. It plays a major role in both geological and biological processes. On Earth, it's found in amino acids, proteins, and other essential building blocks of life. It's also deeply connected to volcanic activity, often present in magma and volcanic gas. And some meteorites, they bring sulfur with them too. So what does it mean to find so much sulfur at the lunar South Pole? Well, it opens up several fascinating possibilities. Maybe this region experienced ancient volcanic eruptions. Maybe it was hit by sulfur-rich meteorites. Or, though it's a stretch, it's not off the table, maybe there were once conditions that could have supported life, or at least the chemical ingredients for it. That changes the whole conversation about the moon's past. It gives us a richer, more complex picture of its history, and could impact how we plan future exploration or even colonization. If certain elements and resources are already present in the soil, it could make long-term human missions far more feasible. Now, shifting gears to the fourth major update, the Vikram lander's CHASE instrument, short for Chandra's Surface Thermophysical Experiment, measured the temperature of the moon's surface with incredible precision. This tool was designed specifically to study how the temperature shifts throughout the top layers of soil around the lunar South Pole. Why is this important? Because understanding how the moon's surface heats up and cools down helps scientists figure out how stable the environment is, knowledge that's essential for future missions, robotic systems, and even building sustainable lunar habitats. These findings are painting a far more dynamic picture of the moon than we've ever seen before, and we're just scratching the surface.
One of the key goals of the Chandrayaan-3 mission was to take a closer look at how temperatures behave beneath the moon's surface, especially around the South Pole, a region that's unlike any other part of the lunar landscape. Using a special instrument called CHASE, short for Chandra's Surface Thermophysical Experiment, scientists measured temperature changes at various depths in the lunar soil. What this data gave us is essentially a thermal map of the moon's subsurface, showing us how heat moves and settles beneath its surface layers. The findings? Pretty extreme. Temperatures swing from a bone-chilling -156 degrees Celsius, or -249 degrees Fahrenheit during lunar night, to a blistering +121 degrees Celsius, or 250 degrees Fahrenheit, in the daytime. That's a temperature swing of nearly 280 degrees Celsius, far beyond what we face here on Earth. And it confirms something critical. The moon's South Pole isn't just remote, it's one of the most extreme environments in the entire solar system. Living or working there would require technology that can handle serious thermal stress. But that's exactly why this data is so valuable. It gives engineers and scientists the information they need to design better systems for future lunar missions, whether that's for research stations, habitats, or resource extraction. Chandrayaan-3 marks a bold step forward in our understanding of the moon, and it's a mission that absolutely deserves global recognition. It's not just a win for India, it's a win for space science and humanity's journey into the unknown. So, if you found this fascinating, give us a thumbs up, share this with your friends, and hit that subscribe button for more stories from the final frontier. And hey, drop your thoughts or questions in the comments. What do you think about Chandrayaan-3 and its game-changing discoveries? Thanks for watching, and stay curious. There's so much more to explore.